morning, guys. How are you? Today we're going to discuss conditional probability. Mainly, we're going to give a rule for conditional probability, solve direct examples on it, and we're going to introduce or define independent events, and finally, we're going to solve some exercises. Now, conditional probability from its name, it means that this probability, we need to find the probability of an event under a certain condition. So mainly the definition of it, when we say the probability of an event B occurring when it's known that some event A occurred, this one we name it as conditional probability. We write it as P of B mod A, and we read it probability of B, event B, knowing that A occurs. So we are saying here that the formula for it, P of B knowing A, is equal to P of B inter A over P of A. Now we're going to tell us, guys, what if we want the probability of A knowing that event B occurs or occurred? So knowing that, we're going to put it in the denominator, P of B. Then in the numerator, we're going to put P of A, intersection between the two events. Now, guys, what if we are given P of B mod A and we are given P of A? What can we find? We can find P of B inter A. So P of B inter A, we can write it as P of A times P of B mod A, which is here. Or if it's given P of A mod B, we can write it P of A knowing B times P of B. Let's illustrate our rule by solving our first example. Here, guys, we are saying the probability that a regularly scheduled flight departs on time is P of D equals 0.83. The probability that it arrives on time is P of A equals 0.82. And the probability that it departs and arrives on time is 0.78. We need to find the probability that a plane arrives on time given that it departed on time. Okay, guys. Whenever we have a question about probability, our first step is to do what? Highlight our keywords. So here, departs on time is P of D equals 0.83. Arrives on time is P of A equals 0.82. And departs and arrives, it is that, when we say and, it is that we are using what, guys? Enter. Departs and arrives, it is that P of D inter A is equal to what? To 0.78. So we copy again our given. Now let's choose another color to check what do we need to find. We need to find P of arrives on time given that it departed on time. So we need to find, guys, as if we are saying finding P of A arrives given that it departed on time. So let's put the formula. Again, down what should we put? We should put P of D. And up, what should we put? P of A inter D. Do we have P of A inter D and P of D? Let's check. P of D is 0.83. P of D inter A or A inter D is the same, is 0.78, so we're going to get the answer as 0.94. Okay, guys, let's erase them now and proceed with our exercise. Then we need to find the probability that it departed on time given that it has arrived on time. So, guys, what do we need to find here? P of D given A. When we say knowing that A occurred or given A, both of them, they mean the same. We are using conditional probability. So according to the formula, it's P of D inter A over P of A. P of D inter A, it's given 0.78. P of A is given 0.82. So we're going to get the answer as 0.95. Okay, guys, let's move now and define what do we mean by two independent events? So we are saying that two events are said to be independent if P of B knowing A, it doesn't depend on A. Okay? When we say independent, it means that P of B knowing A does not depend on A, so it's equal just to P of B. And P of A knowing B is equal P of A, it means that it doesn't depend on B. Here we have a very important remark. We are saying that in case two events are independent, it means that P of A into B is equal P of A times P of B. Okay, guys, let's solve now exercise number 2. We are saying that, suppose that we have a fuse box containing 20 fuses. So, guys, always we have to highlight the given 20 fuses. 5 are defective. Let's give a letter D, defective. If 2 fuses are selected at random, so we are selecting 2 fuses at random and moving them from the box in succession. What do we mean by this one, guys? It means that we're gonna take the first fuse and we're not gonna replace it again. We're gonna just move it from the box, then take the second one. So here repetition is not allowed, okay, guys? Okay, guys. We are saying what is the probability that both fuses are defective. So, guys, we're gonna name our events. We have here 2 fuses. We are selecting the first fuse, second fuse. We need to check when are these 2 fuses are defective. So we're gonna name event A as the first fuse is defective. Event B, second fuse is defective. A into B, what do we mean by it? Both of them are defective. Okay, guys. We need to find P of what? The second, knowing that the first is defective. Or we can find also P of the first is defective, knowing that the second is defective. Why do we have to find it? In order to find what, guys? In order to find P of A into B. So we need to find either P of B mod A or P of A knowing B. Okay, guys. So we put our given. We are saying here that A, the first fuse is defective. B is the second fuse is defective. Guys, if it's easier for you, we can name it as D1, the first fuse is defective. D2, the second fuse is defective. This is just, we are naming the events and we have the right to name them as we wish. Okay, guys? So, guys, let's find P of A. P of A, it means that the first fuse is defective. Guys, first fuse is defective. Here we have many fuses, right? In which what, guys? We have 5 defective and 15 that they are not defective, and the total is what? 12. So if we are taking just one, the first, are moving one fuse from it, what's the probability that this fuse is defective? The total is 20. The number of defectives is what? 5. So the probability that one that we select is defective is 5 over 20, which is what? 1 over 4. Is it clear, guys? Okay. Now, guys, what do we need to find? We need to find P of B knowing A. So what do we mean by it? It means that we need to find the probability that the second is defective. Second is defective. Knowing what? Knowing that the A is defective. So, guys, A is defective. It means that the one that we selected, the first one, is defective. So, guys, let's look. The 15 that are non-defective are still here the same. The 5 defective, they become what? 4. So the total here that we have is what? 19. We are removing 1 now from it. So the probability of this one is the number of defective now under the new condition is 4. The number of the total is what? 19. Okay? So P of A is 1 over 4. P of B mod A, or knowing that A occurred, is 4 over 9. Okay, guys, can we apply now the rule we just mentioned before? How can we find P of A inter B? So let's substitute in the formula that we have for conditional probability. P of A knowing B is what? P of A inter B, sorry, is P of A times P of B mod A, which is 1 over 4 times 4 over 19, which is 1 over 90. Okay, guys, let's move now and solve another exercise. Here we are saying one bag contains 4 white balls, 4W, 3 black balls. The second bag contains 3 white balls and 5 black balls. So we sketch them. This is bag 1, so we put 4W1, it means that 4 white in bag 1, 3 black in bag 2. We have 3 white in bag 2 and 5 black in bag 2. Sorry, this one 3 black in bag 1. Okay, guys, we are saying that one ball is drawn from the first bag and placed on sun in the second bag. It means that we're gonna remove one ball from here and put it here in a way randomly. Okay, guys? What is the probability that a ball now is drawn from the second bag is black? Okay, guys. Let's think about it together. Here we are saying that for the ball to be black from the second bag, we have 2 options. Either the one that we removed from bag 1 here is white, or it's black. Do we have another option? Now, if we have also here, let's say 2 red, then we're gonna have 3 options that, or it will gonna be the first one red, right? So, either both balls are black from the bag, first bag and second bag, or ball 1 is white and ball 2 is what? Black. So what will be the probability of B? Probability of B1 into B2 plus, because why plus? Because we have or, plus B of W1 into B2. So again, guys, we are saying here that we're going to remove a ball from bag 1 and put it in bag 2. We need to find the probability that the second or the ball that we are drawing it now from bag 2 is black. So the probability, it will be depending on what? On what we removed from bag 1. So either we're going to be removing a white ball here or a black ball. So let's find these probabilities. First, what's the probability of having here B1, removing here B1? 3 out of what? 7, because the total is 7. What's the probability of moving here W1, is that choosing a white color, is 4 out of what? Out of 7, right? Now, P of B2, knowing B1 is equal to what? If we removed here B1, let's sketch the figure again. So, we're going to be having 5B2 plus, we're going to be having 1B1 and we're going to be having 3W2. What's the total now in bag 2? 3 plus 1, 4 plus 5, 9. So the probability that we're going to get here a black ball, knowing that we removed black ball from bag 1 is what? 6 out of 9. Okay, guys? And we put it here. So what can we deduce here? That P of B1 into B2, it's P of B2, knowing B1 times P of B1, which is 18 over 63. Now, guys, we're going to tell us, what if we remove white one? We're going to get here 4 white, which is 1W1 and 3W2, and black, we're going to stay the same. So here, total is 9. The probability of B knowing white is what? 5 out of 9. So what can we find now? We can find P of W into B. Let's find it together, guys. So we're going to find it the same. Finally, what should we put? We should add them. Again, why did we add? Because what do we have? Or. We had here 2 cases, so we have or. Okay, guys, let's solve now exercise number 4. We are saying here that a small town has one fire engine and one ambulance available for emergencies. The probability that, again guys, whenever we have a question about probability, the fire engine is available, the probability is 0.98. The ambulance is available, the probability is 0.92. In the event of an injury resulting from a burning building, find the probability that both the ambulance and the fire engine will be available, okay, assuming what? They operate independently. Okay, guys? What do you mean again by independent events? For A and B to be independent, it is that P of A inter B is what? Is P of A times P of B. So what do we need to find here? Both. When we say both, it means what? It means that intersection. So guys, we're gonna name each one, we're gonna give it a name. A, we're gonna say that the event such that the ambulance is available. B, the fire engine is available. So P of A inter B is P of A times P of B, and we substitute. Okay guys, let's solve now exercise number 5. We are saying here that an electrical system consisting of 4 components, this is the scheme of it. It means that P of A is 0.9, P of B is 0.9, P of C is 0.8, and P of D is 0.8. The system works if components A and B work, and so we are saying that for the system to be working, A and B should work, these two ones should be working, and C works or D. So for the system to be working, either we have A and B working and C, or A, B, and B, or A, B, C, and D work. If A doesn't work, the system doesn't work. If B doesn't work, the system doesn't work. If C and D, both of them do not work, then the system does not work. Okay, let's check our questions here. And we are saying what? The 4 components work independently. So great. What do we need to find? The probability that the entire system works. So guys, as if what do we need to find? As if we need to find A intersection B intersection C union B. Okay? Probability of this one is probability of A inter B times probability of C union D. Why? Because they work independently. P of A inter B is the same as P of A times P of B. Again, why? Because we are saying that they work independently. P of C union D, who's gonna remind us what's the formula of it? P of C plus P of D minus P of C inter D. And P of C inter D is P of C times P of D, again, because they work independently. So we're gonna get this answer. Now, in part B, we are saying that the component C does not work, given that the entire system works. Okay, guys. So here we need to find P of not C. Okay, C bar, C prime, C power C. We can write it anything of these ones, knowing that the system works. So here we found the probability when the system works, which is 0.7776. So guys, let's solve this one. We need to find the probability that C, the component C, does not work, knowing that the system works. This one is P of C doesn't work, and intersection system works over system works. System works, we know its probability. Let's find the probability of this one. The probability of this one, C doesn't work and the system works. This one, it means that C bar intersection A inter B inter D. Okay, why? Because if D doesn't work, the system will not gonna be working. Besides, C doesn't work, so D should be working. And A and B, they are a must for the system to be working. Now we said that they are independent, so we're gonna get P of C bar, P of A, P of B, P of D. P of C bar, we're gonna remind us it's equal to what? So P of C bar is 1 minus P of C. Again, guys, when we say C bar or not C, they both mean the same. It means that the event C doesn't occur. We're going to substitute and get the result. So again, guys, we are using these formulas because all components here or all events, they work independently. Okay, guys, let's now solve an exercise about cards. Anyway, guys, how many cards do we have in a poker hand? We have 52 cards. Here we are saying that 3 cards, so let's highlight 3, are drawn in succession without replacement. We are not replacing them again from an ordinary deck. It means that it contains 52 cards. We need to find the probability of the event A1 enter A2 enter A3 such that A1 is given that the first is a red ace, A2 the second is 10 or jack, A3 the third is greater than 3 but less than 7. So guys, let's find each probability of this event alone. Of A1, what's A1 again, guys? First is a red ace. Okay, how many aces do we have in an ordinary deck for cards? We have 4 aces. 2 of them are black, and 2 of them are what, guys? 2 of them are red. So probability of A1 is 1 plus 1 over the total number of the sample, which is 52. Okay, guys. Now, of A2, the second is a 10 or jack. Again, guys, here the cards. We removed 1. We were having 52, then we're going to be having what? 51, because we are not replacing it again. So, probability of A2 knowing A1, how many 10s do we have? We have 4 10s, 2 black and the 2 red. And how many jacks do we have? 4 jacks. So, it's 4, either 10 or jack, 4 over 51 plus, because or, 4 over 51. Now, we remove 2, the first and the second. How many do we have now? 50. So, if we want to find of A3 knowing A1 and A2, it's what? What's A3? The third is greater than 3. It means that it can be 4, it can be 5, it can be 6. It's greater than 3. It means that it cannot be 3. And it's less than 7. It cannot be 7. How many 4s do we have? 4. How many 5s do we have? 4. How many 6 do we have? 4. So what's the number here? 4 plus 4 plus 4, 12. Out of what? Out of 50. Okay, guys, we put the answer. Now, what do we need to find? Of A1 enter A2 enter A3. Guys, how can we write it? Of A3 knowing A1 enter A2 times of A1 enter A2. Again, P of A knowing A1 enter A2, we know its answer. And this one, P of A1 enter A2, it's P of A2 knowing A1 times P of A1, we know its answer. So we're going to get this one as our final answer. Okay, guys, let's now solve our last exercise for today. Here we are given, whenever we are given the probability, a question about probability as a table, it will gonna be easier. Because from the table, we can find all our answers. So here we are seeing that a random sample of 200 adults are classified below by sex and their level of education. So the education is divided as elementary, secondary, college, and the sex is divided into female and male, and here are the numbers. Usually, in such exercises, we recommend to add here a column, to add here a row and here a column to put the total number. Here we are saying that if a person is at random from this group, find the probability that the person is a male, given that the person has secondary education. So, guys, we need P of M knowing as, P of male knowing that the person has secondary education. Secondary education, what's the number of them? Secondary education, 50 plus 28, so 78. Okay, out of the total, which is 200. And male, what's the total for the male, guys? 38 plus 28 plus 22. So we're gonna put 38 plus 20. Sorry, guys. Male intersection as male. Total number of males is 38 plus 28 plus 22. But here, what do we want? We want P of male, and to be secondary, it will be what? It will be 28. So we're gonna put 28 out of 200 over 50 plus 28 out of 200. Okay, guys? So again, P of M knowing S, we can directly put the answer in this way. P of M knowing S, we have here 28. Knowing S, the total number of it is what? It's 78. So directly we can put our answer as 28 over 78 from the table. Or we can use the formula that we put. We find P of M into S, and we find P of S. Okay, the person does not have a college degree, given that the person is a female. So P of F, guys, is what? Female, 45 plus 50 plus 17 out of the total, which is 200. Does not have a college degree. So we need P of C bar intersection F over P of F. P of C bar intersection F, it is that this female does not have a college degree. So it can be having either an elementary degree or a secondary degree, but she does not have a college degree. So it will be 50 plus 45 out of 200. So we're going to get 50 plus 45 over 112. Of course, guys, both of them, this one is over 200. And this one is over 200, but we removed them together because we have 200 and 200. Okay, guys? Or we can, as we said before, we add a row for the total and a column for the total. This exercise, guys, we are done for today's lecture. Let's sum up everything that we discussed throughout the lecture. So mainly we introduced conditional probability, and we said that whenever we have a question about conditional probability or about probability in general, our first step is to find our keywords, highlight them, and give a name for the events. And we talked about the rule. We solved some exercises about it. Then we talked about independent events, and of course we solved exercises. And we solved some exercises about conditional probability by giving a table. From now till we meet during the next lecture, please all of you stay safe.